back to here. Go off here. So before break, a lot of you were working with solving systems, and we've been working with the substitution method. I thought this was a good chance to explore and practice working with the linear combination method. So we're going to learn that method today, or hopefully review that method for you. Linear combination is putting two things together. When we have a linear, we multiply by a slope, a rate of change, and then we add it to something. So that's kind of the idea. We're multiplying our variables by a constant, their own slope or rate of change, and add them together. So let's look at an example. Pythagoras went to buy chips and pop for a party. Chips cost $2.49 a bag. Pop costs $1.29 for a 2-liter. He has $20 to spend. So we start off, what are our variables? The things that change are how many bags of chips we buy, how many bottles of pop he buys. So we use C and P just to kind of make sense with that. Our linear combination will be 2.49C plus 1.29P equals 20. The 2.49C comes from the chips cost $2.49 for each bag. So 2.49 times C is how much you're spending on chips. That's your linear idea, constant times a variable. Same thing on here. For the pop, $1.29p. So how much you spend on pop is $1.29 times how many bottles of pop you buy. You add them together, there's your combination to get your $20. This is the idea of writing an equation with a linear combination. It's a common type of equation you have to write when doing story problems. So when we're looking at these equations, what happens if we have a system of equations that are in this form? Something times x, something times y equals a number. So we have this system here, and when we graph it, we can see pretty clearly that, yeah, we have our solution here at 4, -2. It's where they cross. But now we're going to add these two equations together. So when we add up equations, we have to make sure the equal sign lines up. And then on each side, we're adding like terms. So the x's we add together, the y's we add together, the numbers we add together, but they have to be on the same side of the equal sign when we do that. So we kind of go ahead. 3 plus 2 is 5. 5 plus 7 is 12. 2 plus a -6 is a -4. That gives me my new equation. When I add those two equations, 5x plus 12y equals -4. What good does that do me, right? But if you graph this new equation, you notice it also goes through the point 4, -2. So we get a new line. What does that new line have in relationship to my system? Nothing except that it does still go through the solution point to the system. So we need to do this. Can help us if we're smart about it. Because 5x plus 12y equals -4 is just as bad to solve as the other ones. So this is what we're going to do. We're going to multiply each equation by some number before we add them together. And you'll see, so in this case, I'm going to take the first equation by 2, the second by -3. You notice I need to multiply both sides of the equation by the same number, but each equation I can multiply by a different number. When I get done, you notice I have 6x and I have a -6x. This is what we're looking for. Because now when we add the equations, 6x minus 6x goes away. It's eliminated. And that's our goal. So we'll see that when we add these two equations together, we just get the equation y equals -2. Now, that tells me something. When I look at that equation, just like before, I add the two equations together, I get another line that goes through that solution point, But this line is y equals -2. That tells me something. That tells me my y coordinate. And that's where I can make use of this. Now I know what y is. I just need to find x. To find out what x is, I just plug that into one of the equations and I solve. It's a little bit more work to find the other variable than it was in substitution, because in substitution you had an equation all set up, already solved. You just evaluate it. Here you have to plug it in and actually solve the equation. It's always also a good idea, though, to check. So I used the 3x plus 5y equals 2 to solve. Let's quit doing that. So I'm going to use the 2x plus 7y equals -6 to check and make sure it works. I plug the -2 into that equation, and I plug the 4 and -2 in there, and I get -6 equals 6. It checks, so it must be the right solution. So when you're using this method, remember, the equations need to line up to use linear combination. Line up the equal sign. Make sure we line up like terms. The trick to doing this is to make it easy on yourself. If one is positive and you need one to be positive, one to be negative, so they cancel. If you already have that, that might be a way to work. Be careful with negative numbers, and be sure to check your answer. So, take a look at this problem. 5x plus 3y equals 8, 7x minus 4y equals -38. Try to do this problem on your own. Pause the video, work through, see if you can solve this problem using linear combination. When you have an answer, or if you get stuck and you don't know what to do, start the video back up and I'll work through it for you here. So I'm going to work with y, since one y is positive and one is negative, so I don't have to worry about getting opposite numbers there. To figure out what to multiply by, I need the same coefficient, the same number in front of the y, so I kind of did like I do with common denominators. I take 4 times this one and 3 times that one, so I get 4 times 3 is 12, 3 times 4 is 12, so I can get that same number. And remember, I already have opposites because that's built into this problem. Otherwise, I would need, like on that first one we did, make one negative. When I line this up now, the 12y minus 12y cancels out, and I get 41x equals a -82. I can divide by 41 to get x equals a -2. I plug x equals -2 into the first equation to get 5 times -2 plus 3y equals 8. So I can solve that. Let's get my little thing to disappear. I get y equals 6. So I'm going to check that in my other equation. When I plug in x equals -2, y equals 6 in the 7x minus 4y equals -38, I get -38 equals -38. So it does check. So that's my solution. Last thing, I'm going to write my solution equals and give the ordered pair. So we've looked at doing it with graphing, with decimals. We've looked at it with substitution. Now we're looking at linear combination. When do you use which? If one of the equations is already solved for a single variable, if you have y equals mx plus b, substitution is easiest. If you look at it and you can really easily put one of the equations in that form, substitution is easy. If all of your equations are the exact same form, you can line them up. Linear combination might be the easiest way to go. If trying to solve it, put it into slope form, y equals mx plus b, means you have fractions, I'd use linear combination so I don't have to deal with fractions. Graphing or a table is great if you want a quick estimate, if it's not linear problems. We've just been focusing on linear ones, but sometimes they aren't, in which case, hey, graphing would be great. So I also gave you worksheet to work on. Work on those problems. Take a picture of your solutions, take a picture of your work, and upload it back onto Classroom, and I will look that over and I will give you some feedback. So have fun with this and enjoy your break.